Hello students. Today we continue our lecture on organic chemistry. This lecture is being presented by me, Pranit Ghatak, your chemistry teacher. So let's begin. As you all can see from the heading itself, today's topic will be alkane, alkene and alkyne. Okay? So let's begin. Here in this slide you can see that is hydrocarbons is being classified into two types, that is saturated hydrocarbons and unsaturated hydrocarbons. So before classification we should know what is hydrocarbon. Hydrocarbon is basically those elements or those compounds that are being formed with the help of only carbon and hydrogen. Yes, there may be any heteroatom can also be present, that is oxygen or nitrogen can also be present in that compound, but it is mandatory in hydrocarbons that hydrogen and carbon, both of these elements must be present. Okay, if any compound consists of hydrogen and carbon as a main constituent of that compound, then that compound will be called as hydrocarbon. Okay, and hydrocarbon is classified into two parts, that is saturated hydrocarbon and unsaturated hydrocarbon. So what do you mean by saturated hydrocarbon? Saturated hydrocarbon means in that compound when we react with hydrogen, there will be no further addition of hydrogen. That is being called as saturated hydrocarbon. So when in a hydrocarbon, if we react with that hydrocarbon with hydrogen, then if there is no further addition of hydrogen is being taking place, then it will be called as saturated hydrocarbon. Okay, saturated means it is full of hydrogen. Okay, it is full, it cannot take more hydrogen. Okay, so it is being called as saturated. Okay, it is being saturated means full, it is full of hydrogen, so it cannot take further hydrogen at all, so it is being called as saturated hydrocarbon. And what is being called as unsaturated hydrocarbon? Where if we attack or if we react hydrogen with these hydrocarbons, if the number of hydrogen is increased or the compound itself accept some hydrogen, then it is being called as unsaturated hydrocarbon. That is, it is not filled. Okay, it is not full to accept hydrogen. So as it is incomplete, so it can accept hydrogen. As it is incomplete, it is not saturated, so it is being called as unsaturated. So to summarize it, we can easily say that in case of saturated hydrocarbon, that means it only have a single bonds. Okay, single bonds are, if in a compound there is only single bond, so that is being called as saturated hydrocarbon. And saturated hydrocarbon example is mainly alkane. The general formula of alkane is CnH2n plus 2. Okay, as you can see from the slide itself. Okay, so saturated hydrocarbon is basically being represented as alkane, and alkanes are having the general formula of CnH2n plus 2. So if a compound having only single bonds, that is being called as alkane or saturated hydrocarbon. If any compound having double or triple bonds, then it will be called as unsaturated hydrocarbon. If a compound having a single or more than one double bond, then it is being called as alkene. Okay, and the general formula of alkene is CnH2n. Okay, if a hydrocarbon having a triple bond, at least one triple bond in that compound, then it will be called as alkyne, and the general formula of alkyne is CnH2n minus 2. Okay, so these are the introduction of hydrocarbons. Hydrocarbons are basically those elements, those compounds which is having main components of carbon and hydrogen. There may be another heteroatom may be present in that compound, but the main constituents of that compound is mainly carbon and hydrogen. Okay, and this hydrocarbon can be classified into two parts, that is saturated hydrocarbon and unsaturated hydrocarbon. Saturated hydrocarbon are those are only having only single bonds, and this is being called as alkane, and the general formula is CnH2n plus 2. And the second one is unsaturated hydrocarbon, and the unsaturated hydrocarbon are basically of two types, that is alkene and alkyne. So any hydrocarbon that consists of one or more than one double bond, that will be called as an alkene, and the alkene having a general formula of CnH2n. Okay, and any hydrocarbon that is being having a triple bond or more than one triple bond, then it is being called as alkyne. Its general formula is CnH2n minus 2. Okay, so this is being the introduction of alkane, alkene and alkyne. So before we start with the and one more thing, the preparation of alkane, alkene and alkynes is not in our syllabus right now. According to the further reduced syllabus that is being provided us by the council itself, there is no provision for the preparation of alkane, alkyne and alkene. As the preparation of this alkane, alkene and alkyne is being removed, so we have to only understand the concept of nomenclature, isomerism, that is IUPAC nomenclature, isomerism, that is organic isomerism, as well as the chemical formula and the general formula of alkene, alkyne and alkynes, as well as saturated and unsaturated hydrocarbon. There is a classification of that, and the properties, mainly the chemical properties, are very much important in the case of alkene and alkynes. Okay, so before we start with the properties, that is mainly the chemical properties of these three, we have to know mainly the chemical properties of alkane and alkyne is mostly important, then alkyne is not so much important at all. Okay, but we should know that as well. Okay, so before we going into the chemical properties, we have to know the sigma bond and pi bond. Okay, so here in the case of I will be making a chart on that. Okay, what happens, suppose yes, so this is the name of the bonds, this is the bonds. Okay, and this here, this is the sigma and this is called as pi. So bonds are mainly two types, there is sigma bond, this is called sigma, this is called sigma. Okay, and this is being called as pi bond. Okay, so here the bonds, as the bonds are mainly two types, so in the case of single bonds, there is only single bond, there is only one, if there is only one bond that is being called as single bond, then that bond will be a sigma bond, there will be no pi bond. Okay, if there is suppose double bond, that is two bonds are there, then one will be sigma and one will be pi. Okay, and if let assume there is a triple bond in a compound, then the sigma bond will be 1, it will be constant 1, but the pi bond will be 2. Okay, so as here in the case of bonds, the single bond consists only a sigma bond. Okay, in the case of double bond, there will be one sigma and one pi. In the case of triple bond, there will be one sigma and two pi. So the number of pi bonds will increase. The number of pi bonds will increase down when we go from single bond to double bond, single bond, double bond, triple bond. But the number of sigma bonds in any bond, that is single bond, double bond or triple bond, is the same. So number of sigma bond is constant, that is 1. Okay, so the when the pi bond is 1 or 2, if there is in any bond, if there is pi bond, so that hydrocarbon is being called as unsaturated compound or unsaturated hydrocarbon. Okay, as in the case of single bonds compound, here there is no pi bond because the single bond means only one bond, and that one bond is basically sigma bond. As there is only sigma bond, so that will be called as the saturated hydrocarbon. If there is pi bond is present in any compound, in any hydrocarbon, then it will be called as unsaturated hydrocarbon. So remember, for single bond there is only sigma, for double bond 1 sigma 1 pi, for triple bond 1 sigma 2 pi's. Okay, so please take a note on that as well. Okay, so let's move to the properties, mainly the chemical properties of hydrocarbon. Here we know there is CH4. As we know, CH4 is being called as methane and is the alkane, because in the case of CH4 all the bonds are single bond, so it is being called as methane. But you may not have, or we may not have know the all the structure of the compounds, so it is difficult for us to remember all the structure at class 10 standard. So we have to know that which compound is alkane, or which compound is alkene, or which compound is alkyne by the general formula. Here the carbon having a general formula of carbon, number of carbon is 1 and hydrogen is 4. So as it's verify the CnH2n plus 2, CnH2n plus 2, that means where if we place 1, then it will be C1H2 into 1 plus 2, that means C and H, 2 into 1 means 2 plus 2, that is 4. So CH4 validates the alkane general formula, so it will be alkane. Okay, so in that way, using general formula, we can know which one is alkane or which one is not. Here the number of carbon, as the number of carbon is 1 and it is alkane, so it is being called as methane, that is meth plus n, it is being called as methane. Okay, so when methane is being reacted with chlorine, it will be first in presence of H mu, this is called as H nu. H nu. So H nu basically sunlight. Okay, sunlight or UV. So in presence of sunlight, if we use methane while reacting with chlorine, it will form first, it will substitute one hydrogen with chlorine and it will form CH3Cl, that is chloromethane. Then if this reaction goes on and it will eventually form, that is CCl4, that is tetrachloromethane or carbon tetrachloride. Okay, so first it will only substitute at any stage of reaction, it will only substitute one chlorine, one hydrogen with one chlorine. So CH4, one hydrogen is being removed, so CH3 plus chlorine, that is CH3Cl. Then in case of CH3Cl, this CH3Cl, it will remove one hydrogen, it is replaced one hydrogen will be replaced, one hydrogen will be replaced by chlorine, so CH2Cl2. Then the CH2Cl2, then hydrogen will further be removed and chlorine will be added, so CHCl3. Then CHCl3, that is chloroform, it will further react with chlorine, and in presence of sunlight, it will also, the hydrogen of this compound will also be replaced with chlorine and it will form CCl4. Okay, in every step of the reaction, so one HCl compound or HCl molecule will also produce. Okay, so this is the overall reaction of being an alkane, that is a methane. We have taken example of a methane, when methane is being reacted with chlorine. Okay, so this all the things will go on. Okay, and the second reaction is very much important reaction here, that is complete and incomplete combustion. When an alkane is being reacted with oxygen or burn in presence of oxygen, it will do a combustion. Okay, but if the amount of oxygen is higher, then it will do a complete combustion. If the amount of oxygen is lower, then in the limited supply of oxygen, it will do a incomplete combustion. Okay, in the case of excess oxygen, it will do a complete combustion and it will further produce carbon dioxide and H2O. Here in the case of C8H18, that means it is a octane. Okay, that means C8 means oct plus N, that is octane. Okay, so in the case of octane, when it is being burning in presence of, it is being burned with in presence of oxygen, it will produce 8 CO2 and 9 water molecule. So whenever there is a complete combustion is occurring, it will only produce carbon dioxide and water. But here in the case of incomplete combustion, there will be a limited supply of oxygen. If there is limited supply of oxygen, then the burning will not be completed and the oxidation will not be happen totally. So what happened, when in the case of CH4 is being incompletely oxidized, it will form only carbon monoxide or any with respect to any alkane. It is not valid for only for methane, it is valid for all the alkanes. Whenever an alkane is being incompletely combusted or incompletely oxidized in presence of limited supply of air, then it will form carbon monoxide, not carbon dioxide. It will only form carbon monoxide and water. Okay, so water is being the same for both of the cases. It is there for complete combustion as well as for incomplete combustion. But here in the case of complete combustion, the CO2 will be produced, but in the case of incomplete combustion, as the limited supply of air, limited supply of oxygen rather, so that is why it will only produce the CO, that is carbon monoxide. Okay, so in the case of incomplete combustion, there will be a carbon monoxide plus water, but in the case of complete combustion, there will be a CO2 plus water. Okay, so this is the difference between the complete and incomplete combustion. Okay, so this is the chemical reactions for mainly alkanes, that is for methane and octane. And now we move to the next topic, that is being the alkenes. Alkenes means wherever there is a double bond in a compound, if one or more than double bond is there, then it is being called as alkene. And simple example of alkene is C H2, that means C2H4. So it is being called as ethene, as it is having a number of carbon 2, so eth plus ene, that means ethene. When ethene is being reacted with chlorine, here the double bonds, here we can see that there is a double bond, and in this double bond one is sigma, another is pi. So this pi bond will be removed, and in presence of pi bond, two chlorine atoms will be placed. So pi bond is being replaced with chlorine, okay, chlorine atoms, and there will be two chlorine atom will be placed in two different carbon atoms in ethene. Okay, so this is a simple reaction. Here in the case of chlorination of ethene, what happened, mainly chlorine replaced the two chlorine atom, replaced the pi bond that is being there in the case of ethene. So the new compound is being formed, and this new compound is being called as dichloroethane, and this is the addition reaction. Okay, here this is being called as addition reaction. Okay, because here this chlorine atoms are being added. Okay, so it is being called as addition reaction. Okay, here we cannot, there is no substitution because the hydrogen is being not substituted, not replaced by chlorine, so it is being called as addition in the case of alkenes. But in the case of alkane, here you can see that this one hydrogen is being replaced by chlorine, so it is being called as substitution reaction. So chlorination in the case of alkane, it is being a substitution reaction, but chlorination in the case of chlorination or bromination, in the case of alkene, it is a addition reaction. When double bond is there, that is mean addition, there will be addition reaction, but when there is alkene, in the case of alkane, there will be a substitution reaction. So substitution means replacement reaction, and addition means just it is being added. Okay, here chlorine is being added, not substituted or replaced. The same goes for the bromination reaction as well. Here the pi bond is being replaced, pi bond is there, and it is being removed by bromine, and the two bromine atom will be there. The two bromine atoms will be added to the ethene, and this will form 1,2-dibromoethane. Okay, and this is also addition reaction as well. Okay, and the last thing here in the case of acetylene. So as you know, ethane, in this symmetric data, symmetric chart, you have find that in the ethane, all this compound, all the bonds are single bonds, so it is being called as ethane because it is alkane. So number of carbon is 2, so eth plus n, that is ethane. In the case of this compound ethene, that is here there are double bond, as the double bond, so it will be a alkene. And here in the case of acetylene, it is being called as ethylene. And here ethylene or acetylene, the common name is acetylene, it is more famous on that as well. Okay, in this name, the acetylene is here there is triple bond, you can see that here. Okay, in this compound, as the triple bond is there, so it is being alkyne, and the name is ethylene. Okay, the common name is acetylene. Okay, here the general formula, as we know, CnH2n-2. Okay, so in the syllabus, the bromination, chlorination as well as the combustion reactions are there. I have discussed it here as well. So if you have any doubt regarding this topic, please ask me in the comment section below. So thank you very much. Bye.